In this problem, we're shown a parallelogram and told to solve something about it. In particular, we're told all the sides, A, B, C, and D, and we're given one of the angles here. And we're asked, what is that angle right there? Now we're going to use the law of cosines to solve this one. You might not see how at first, but it should not be too hard once you realize that a parallelogram, I'm sorry, I keep saying that, a quadrilateral is just two triangles sort of mushed together with this as this diagonal line here as the divider between the two of them. Okay? So what I want to do is imagine for a moment that we have just this triangle. And what I need to know is that unknown side right here. So I'm going to label these things 22, okay, according to what I'm given on the top of the problem. There's my two sides, 22, 16, oh, and I have a 123-degree angle right here. So let's take all this information that I've been given about that system and put it down here, okay, and solve for this side, which I'm just going to label C because I can, and I don't care what the original labels were over here, okay? The fact that there's four sides, A, B, C, and D, and they don't really correspond to what you're normally used to looking at in a triangle might mess you up. So go ahead and relabel it. It's your triangle. You can label it whatever you want. So I'm going to say I'm looking for side C. Therefore, according to the law of cosines, C squared equals, do we remember our law? I hope so. A squared plus B squared minus 2AB times the cosine of big angle C. Now, what's that big angle C? Well, that's this 123 degrees thing. So we punch all these numbers in, and we're going to get something for C, right? Remember to square root it. Don't forget the square root you need. So now pretend you know that. I'm gonna only go over this in the idea. I'm not going to go through the calculations because we've been through those in a bunch of other situations. So now you know side C. You come back to your triangle and just put that number on there, whatever that is. Okay. Now make yourself another triangle. Okay, we know that side that I just drew. And these other two sides, we also know those from what's given to us in the problem. This one's 26. A over here, that's 15. And I would love to know that angle. That's what we're trying to find now. Okay, so now I have this triangle where you know what C is. You just calculated that in the last step. So we're going to use this information to find my angle C. And notice my angle C in this lower triangle has nothing to do with the angle C in the upper triangle, right? The angle C in the upper triangle, according to those labels, is over here. Who cares about those? We're making our labels as we go here. So just to keep in mind what's opposite angles and what's opposite sides, and you should be able to keep your law straight. Cosine C, according to the law of cosines, is equal to A squared plus B squared minus C squared, those are all sides, divided by 2AB. And now we just plug these numbers in. We know A, okay, that's 26 or 15 or whatever you want. We know C, okay, C is just this thing we found in the last step. And now you take the inverse cosine, you're going to get the angle C that we're looking for. So that's how you approach this problem. There's another version of this problem which asks you for the area of the quadrilateral. And I just want to go over how you would do that. If you're given a quadrilateral like this, okay, you imagine that it's two triangles mushed together, and you're given some information about the sides. Let's call these A, B. I'm just going to label them D and E, okay? Those are your sides of the quadrilateral. If I wanted to know the area, well, I would need to use the law of cosines to find that line that cuts down the middle. Now, check it out. Look at what we have here. We have one triangle right there, and we have another triangle over here. We know the three sides of each of those triangles separately. So I could say the area of the quadrilateral equals the area of triangle number one. I'll call that triangle ABC, plus the area of triangle CDE, right? if I just add those two triangles together. Now, how do we find the area of a triangle if we know three sides? Well, I hope you remember Heron's law, or Heron's formula, right? That one was a very simple formula. It's that the semi-perimeter equals 1/2 of, I'm going to use the top one as an example, a plus b plus c, and then the area equals the square root of, this one kind of gets to be a pain in the neck, honestly, s minus a, s minus b, s minus c. Okay, so if you're lucky enough to have a combo problem that asks you for the area, this is the way you approach it. You'll find the area of the two triangles separately by using the three-sided formula, Heron's formula. If you have a problem instead, which simply asks you for an angle, you're going to use law of cosines to work your way towards that angle by finding the joining side in the middle. That's your connection right here. Once you can find that side, you can use another iteration of the law of cosines to find your angle.